LLMs and function calls. I'm going to call this introductory lecture LLMs and function calls, what's the big deal? And then within this lecture, we're going to go into kind of what's the big deal around LLM function calls and why it's so difficult to pull it off and what exactly you can and can't do with LLM calls. By the end of this lecture, you'll have a good understanding of exactly the types of function calls and the types of lectures that you're going to get from the rest of this course, and the ability to come back and pick and choose from those different lectures depending on what exactly you're looking for. So let's dive into the lecture here. And the function call problem is a multi-step problem. There's multiple reasons why function calls are hard for LLM models. First of all, it's a logic problem, like you actually have to think it through. Secondarily, it's an order of operations problem. You can't just say, do the function, you have to do the functions at certain times and under certain conditions. There's unlimited variables of functions that you can do. There's a plethora and a multitude of things that you can do via functions, and so it's kind of impossible to program in anything that you could do with regards towards functions. And then kind of most importantly for LLM models, functions need to be precise, and we'll dive into each one of these individually. So diving specifically into the logic problem. The function itself is a piece of logic, and this piece of logic has to be written. In order for it to be written, you have to know what the logic is. So the very first hurdle for an LLM model in order to perform a function is that it needs to know what that function is. And there's different ways that you can give the model the ability to utilize functions. The models utilize functions the same way that we do, and then so think of them as tools, and that's the way that the model utilizes them. And then so in order to utilize tools, generally you have a toolbox. There's a place where you get your tools from, and then you either make them or you have a toolbox where you draw them from. And that's kind of the same exact process for the LLM model, right? It either has to make the tool or there's a place where it can get the tool from. And then so within that though, it has to, first of all, the very first step within that is to know that logic behind it. Second step is to actually write out that function. So it's one thing to know it, and then you have to write it. So the ability to actually take that is another step. And then when you want to actually call the function, you have to know that you want to be able to do it, you have to be able to write it, and then you have to be able to call it. How exactly does a notebook work? Where exactly are you calling it from? How exactly does the function work? All of those things go into the logic problem that makes up a function. So if you want your LLM model or your AI model to call functions itself, the very first thing is that you need to embed this understanding in the LLM model itself, or you're not going to get there. So moving on from there, the second step that we encounter is that function calling is an order of operations problem. So in situations where the model needs information to function and from the function to respond, this complicates the function itself massively. And then within that just goes into the order of operations itself, right? So if you want to call the data and then you want to have the model read, let's say website data, and then make calculations based off of that or change its prompt based off of that, you're looking at multiple steps and multiple lines of code that need to be executed in proper orders and proper sequences. And then so it's not just make a web call and then return the information and summarize the results. That's not one process, that's 5 processes. And then all of those need to follow an order of operations and go in sequentially. And if they're out of order, then you're going to run into issues there. Second thing is that read-write logic needs to be defined first, but potentially triggered later on in the function. Most commonly, you don't want the very first thing to be read-write within your function, or read-write logic, right? You want it to do something and then read, or maybe write, read and then do something and then write. So there's steps involved in between. And the biggest thing to keep in mind within this is that the model itself can't keep track of its own order of operations. It's just not. It's something that's built into the models, and it's something that's not going to happen overall. So you have to keep that limitation in mind completely upfront. Moving on, the next thing to deal with is the fact that you have unlimited variables in this occasion. So again, function calls can be built to do any task, and the model doesn't necessarily understand anything about the function itself or the variable. So the model needs to be trained on both of these elements, on what exactly you want it to do and what exactly, like, the entire process around that. Not what's the function, what is it doing, like what is it pulling, what's that data, what's that process look like. Every single step involved, that whole order of operations process comes in here with the unlimited variables, and then you need to do that individual order of operations for each individual variable. So you have kind of like, you can see how this multiplies into a web of related problems, is essentially kind of how this draws out. And then, so the very last and probably, again, most probably significant for the LLM models, but very specifically, is that functions require precision. And then, so LLM models are statistics and probability models. They don't excel at precision. And then also within that, you have another problem, which is that LLM models don't read words and numbers in the same way that a human does. And so both of these elements combine to form kind of a perfect problem where, like, if you're wanting your LLM model very specifically to perform these functions, it's a high level task that you're calling upon it. Like, this is much higher level than, say, translating from English to Spanish or something along those lines. Like, this is multiple steps, multiple order of operations problems, and you're deviating from what the model is intended to do in the first place, which is to be a statistics and probability model, and then you're saying to be a deterministic model, and then so you essentially have to retrain the model in that sense overall. And then, coupling again with that second problem, which is that not only do you have to deal with that first problem, you have to say, hey, so here's what a function is and what it looks like in your language, right? Because it's not going to again, like, if you think like, okay, here's a book that I could give you, just here's the words, like the LLM model is not going to read those words straight up or understand those numbers straight up, is like what I'm trying to get across with this. And then we'll dive a little bit deeper into this exact concept because it's a little bit tricky. So this specific concept is called word vectorization. And then word vectorization is very specifically how an LLM model views letters and numbers. So from letters to vectors. LLMs, they don't see words like people do. Each letter is converted into a numerical vector, creating a multidimensional representation of the word. In general, and there's different methods, but so in general, you're talking about a number that's between like 0 and 1, or like between, like, it could be like between like 0 and 201, between like 1, 256, or 1 and 1,000, depending on exactly what the vectorization method is and what exactly you're trying to accomplish. But like 80% of the time, it's going to be a number between 0 and 1. So you'll see, and it'll be multiple numbers, right? So like the word king might be a number that is, I'll just make these up, like 0.4, 0.6, 0.7, and 0.5, and that equals the word king to the LLM model for whatever we know this under a particular vectorization method. Just a random example. And then so, again, like, that is how the model itself is seeing those words. Like, so the word king, 0.7, 0.6, 0.8, 0.4. It's not seeing K-I-N-G, and it's not seeing it in any language, right? It's just seeing these numbers, and then these numbers mean different things depending on different word vectorization methods. And then so that's the other thing to keep in mind here, is that there's different methods that you can use, and then using methods changes the way and the numbers and all of that within the equation. And that's kind of where this second bullet point here comes in, of semantic space, that these vectors live in a high dimensional semantic space where similar words reside close to each other. So think of king and queen as neighbors in this in this space. So within that, you have like different relationships and different situations that can occur in different ways that the model can read and interpret king and queen in this particular context. So It can, if there's and the context that the king and queen are used also changes. So the models can build off of like the context of the words as well. And then so all of this goes into essentially framing how the AI model actually views these words. And then beyond words, you have numbers and punctuation. And then so how do you deal with that, right? And then so how you deal with that is that numbers and punctuation generally get their own vectors. And then so like the number, like if it's, you have word vectors and number vectors. And then so the number 1 is vectorized into a symbolic symbol for the LLM model. It's just, like, so all of this goes back to like symbolic meaning and symbolic relationships. And that goes back into why this is difficult when it comes down to precision, because you're not actually getting precision from these models. You're getting symbolism, and you're dealing with symbolism from a model that is built off of predictability and statistics rather than determinism. Like, it's not a calculator up front, right? And then so you're kind of asking it to be a calculator, and then that's a challenge for the model. So how exactly do you get the model then to be a calculator? So before we get there, the very last thing to understand within this problem is the last reason why this is difficult overall for LLM models to understand. So let's say that you get past all of these problems, right? You get past the order of operations problem, the logic problems. You get the model to understand what the function is and what you want it to do within the function, etc. The very next and the very last problem that the model has to face is how does it actually call that function and interact within the environment of within the notebook environment, right? And then so you can think of the notebook in this instance like the house for the LLM model. I think that's a good example. So if the LLM model lives in the notebook, it lives in the house. How does the model interact with the house, right? Because in this instance, then the LLM model doesn't actually live in the house. Like when we think of the actual concept of the LLM model, it's just algorithms and math and statistics. That's what it is, right? It doesn't have a physical form. Like, it doesn't physically exist within a physical notebook. But then what you're asking it to do is a physical task. You're saying reach into the physical world and interact with this physical notebook. And then in order to do that, the model has to know exactly what to do and how an environment works within that. And then so this brings in kind of interesting concepts that come up with around LLM models and around embodied versus disembodied learning and environment learning. And so just framing this like very simply and simplistically overall, the very first studies that were done around this, like embodied versus disembodied learning, were in the 50s and the 60s, involving cats, and they've utilized mice and other animals since then. And then what they found is that among the same animals and the same species and among animals in general, there's a difference between learning from your environment and not learning and interacting from your environment. And how they've done this in studies is like in the famous like passive versus active cat experiment was they put two cats in a cage type of system and then one was able to interact with the environment, and then the other was only able to essentially interact with, like, wasn't able to actually move itself. If the other cat moved, then the other cat would move, and that's how it was able to, like, it had no interactions with the environment. And then when they took the cats out of that system, like from the very first moment that they were born, they put these cats in the system, and then like a few weeks later or a month later, they take the cats out, and then the cat that had no ability to interact with the environment was a very different cat than a normal cat is kind of the bottom line. And then so they've done experiments since then and replicated this, and like so overall when it comes to learning, there's a lot of different elements that go into the learning process itself, and one of the big ones is embodied learning. And then so if you want your LLM model to actually be able to make calls, like if that's your overarching goal, you come into this course and away from this course and you say, I want to build my own model that's going to be able to make calls, make function calls on its own, and like I want it to do it well, and like that's all like you're going to be diving deep into reinforcement learning. It's kind of what I want to bring up within this, and why I'm bringing up this embodied versus disembodied learning. So when it comes to like that training, how do you train the model to do it? It's straight up reinforcement learning, right? Which is environment training. So this embodied versus this disembodied debate, LLM models and AI models, they don't get away from it. It's the same thing as the passive and the active cat. If you want the model to interact with the environment, you have to teach it to interact with its environment. It's kind of the bottom line. And then so within this, we've offered like kind of a lot of like caveats and like what you can't do with function calling. And that's not the purpose of this course, right? The purpose of this course is what you can do with function calling. So let's go ahead and dive here into the last slide. And how do you get LLM models to make function calls? And this gives you kind of a good breakdown of the courses that you're going to, and the lectures that you're going to see throughout this course, because we're going to follow this order and go through these individual methods as to how you can get utilize these different methods for function calling. So the very first method is method 1, external from AI. You embed the function calls directly into the code, and the functions get called based on predefined rules. That's very straightforward. It's the most common and the most frequent and the easiest way to handle all of this. And so if you have like calls that are very basic that you want to happen on very basic logic, here's the rule, here's the input, here's the output, bada bing, bada boom, execute it. It's very easy to do, and so we're going to start there. Second method is external from your main LLM model. So you fine-tune, train either an LLM model specifically on the function calls that you would like it to make, and or you utilize products such as Langflow to do it for like Langflow or LangChain. And then there's drawbacks, and we'll dive deeper into each one of these individual concepts as well, and in each one of the individual lectures. The third method that you can utilize is to utilize OpenAI's API. So most people, they think and they know OpenAI as the maker of ChatGPT, right? But if you look at like the books of OpenAI, a majority of the revenue doesn't come from ChatGPT. It comes from their APIs. And the API that they sell is that they very specifically have dealt with this problem, and they know about this problem overall. And then so ChatGPT and their APIs are a model and a method that can get around this, and so you can utilize their APIs in order to make function calls, because they've very specifically invested billions of dollars into like solutions around this problem via their API. And then method 4 is the method that I don't recommend that you take. Like this is method 4 is the method that you have to be extremely committed to. But I'm sure that there's someone watching and going through this course that is dead set on method 4. So we're going to go through method 4 here as well, which is to train your LLM model very specifically on the function calls that you want it to make. And then we'll get into, again, in each one of these individual lectures, more into like the drawbacks and the pluses and the minuses and everything around each one of these methods. But there's a lot of drawbacks to method 4 and reasons why you don't want to go with method 4. You'd be far better pressed and to choose method 1 through 3 in any other instance. And specifically, I would recommend that if you want to go method 4, that you look very specifically into method 2 instead, and augment your model. But we'll talk about this again more as we get into the lectures. So I'll see you in the next lecture. Thank you very much.